Hello everyone. Today we are going to be working with simplifying radical expressions. This kind of branches off what we did yesterday whenever we were breaking them down into their perfect squares and simplifying, but now we're going to be doing some operations with these as well. A lot of the times, so if you just kind of get in the mindset of doing your normal operations, like multiplication is going to stay multiplication, division is going to stay division, and we will simplify how we normally would with just regular numbers. So for this next part here, whenever we are simplifying, there are a couple of key things that we have to remember. There should be no point in this page that you should have any decimals. So like if your instinct is to just grab your calculator and just start putting square roots in there and finding decimals and writing them down, make sure you pay attention to this next part, okay? Also, another rule is that we will not have any square roots in the denominators, okay? So this will be, it's called rationalizing. Rationalizing. All right, and so things I will keep saying a lot of times is like everything that's underneath the square root is kind of like a like term, if you will. Okay, so anything that's underneath the square root, you can do the operations of. So like in this first one, when I have the square root of 5 times the square root of 5, this actually multiplies, since they're both underneath the square root, you can combine them to be the square root of 25. 5 times 5 is 25. And then we take the square root of it. Square root of 25 is just 5. And that is your answer. Okay, whenever you take your square root of 25 is just 5. So for the second one here, whenever you have the square root of 8 times the square root of 8, that is equal to the square root of 64. They would both stay underneath the square root. Then when you take the square root of 64, it just turns into 8. Might be able to start seeing a pattern here. Whenever you have the square root of 5 times the square root of 5, it just turns into 5. Square root of 8 times the square root of 8 is just 8. So by this logic, square root of 500 times the square root of 500 is just 500. All right, this is something that will come back whenever I try to have no square roots in the denominator, whenever I rationalize between those two. All right. And now if I simplify this expression, so 4/12 is just like any other fraction you've ever done in your entire life. Okay, so you're looking to simplify into the simplest form, so dividing the top and the bottom by the same number. In this case, 4 and 12, I can divide them both by 4 to get 1/3 for your answer. Okay, a lot of other times, you might have in the past, whenever you're dividing, kind of slash out the numerator and the denominator and divide out that way. So like 4 divided by 4 is 1, 12 divided by 4 is 3, and so then your answer is 1/3. Okay, and letter E here, if I had 7/7 as a fraction, all right, these two, whenever you simplify it, is just equal to 1 whole. So a lot of times we could just cancel out like we normally would. Those would be 1s. All right, same thing happens with my square roots. If I have 5/5, they can cancel out to make 1 whole. All right, 6/2. If I do 6 divided by 2 and divide both of those by 2, I would get a 3 in the numerator. So all of this scary stuff just turns into a 3. Okay, because technically, whenever I have the square root of 1, that's just going to equal 1 on both sides. Okay, but the common thing here is outside simplifies with the outside. The inside underneath the square root simplifies with the inside as well. All right, as I move on to letter F here, now things change a little bit. I've got one number, so the 8 is outside of a square root. The 2 is inside the square root. So I can't just simplify 8 divided by 2. So from here, now I need to be like, oh, shoot. I've got this square root in the denominator. So how in the world am I going to get rid of that? So this is what you call rationalizing. So in order for me to get rid of this square root, if I look at a, b, and c here, in order for me to get that square root away, I need to multiply it by itself. So like if I want to get the square root away from the square root of 5, I would multiply that by the square root of 5. So this is what I would do here. If I see that I have a square root of 2 in the denominator, I would have to multiply the denominator by the square root of 2. And that common phrase you probably have heard over and over again is whatever I do to the bottom, I also have to do to the top. Might have seen this as the giant 1. So I have to essentially multiply by a 1. So square root of 2 over the square root of 2 is equal to 1. So now I multiply like I normally would. 8 times the square root of 2 is just 8 square root of 2. But this bottom part just doesn't go away. So I have to actually do the math between it. So square root of 2 times the square root of 2 turns into the square root of 4. Then one step further, square root of 4 is equal to 2. But wait, there's more. You can still simplify like a normal fraction, like we did before. If I have, you go back to outside with outside, inside with inside. So if I have an 8 and a 2 on the outside, just like a regular fraction, I can simplify that by dividing both of those by 2 to get a 4 and a 1. So then my final answer is 4 square root of 2. All right, so from yesterday, you could actually have to break down this square root if you had to, or it is possible. I just ask for you guys before you circle an answer to see if you can divide by a 4 or a 9 underneath there. 4 or 9. If the answer is no, then you're probably good for that. Okay, so for letter G here, okay, I've got the 3. That's the only thing on the outside. Can't really do anything with it. I've got 2 numbers underneath the square root, so I'm going to ask myself, can I simplify first? So 6 over 2, I can divide both of those by 2 to get a 3 in the top, 1 on the bottom. So down here at the bottom, or the top, I would have 3 square root of 3. At the bottom, I'm just left with a square root of 1. Okay, so whenever you have the square root of 1, well, 1 squared equals 1. So the square root of 1 is just 1. You do not have to put that 1 down there at the bottom. All right, but I will not count off for it. Boom. So to check, well, I can't simplify anything outside or inside. I can't divide the 3 by a 4 or 9, so I'm good. For letter H, again, I'm going to look at the outsides. So from here, the 5 doesn't have anything to simplify with. The 3 and the 2 can't simplify 3 over 2, so now I'm like, well, I've got that square root in the denominator. Lots of steps to think about. Good thing we will practice this in class. So to get rid of that square root of 2, I would multiply by the square root of 2. And whatever I do to the bottom, I have to do to the top. Boom. Outside with outside, inside with inside. So the numerator here, this 5 has nothing to multiply with. 3 times 2 here is 6. Boom. Square root of 2 times the square root of 2 turns into the square root of 4, which just turns into a 2. I'm going to look quickly. 5 over 2 can't simplify as a fraction. These are not like terms. 6 I can't divide by 4 or 9, so I am good to go. Some of these take more work than others, which is okay. We can persevere, I think. All right, so letter I here. Hey, we're back to multiplication. No more fractions. Okay, so same thing though. You do outside with outside, inside with inside. So I see the 4 and the 5 on the outside, which is going to be a 20. Square root of 3 times the square root of 3, which is the square root of 9. Some of you guys might skip a step here, which is okay. But then I think to myself, what is the square root of 9? I would do 20 times, now that square root's going to go away to turn to a 3, which is 60. For the next one here, same concept. 5 times 2 is 10. 6 times 3 is 18. But then I ask myself, can I divide 18 by a 4 or 9? 4 or 9. The answer to that is yes, we can. 18 I can branch down into a 9 and a 2. Brings back a blast from the past from yesterday. So then I have 3 square root of 2. I can bring down the 10 to get 30 square root of 2. All right, letter K. I can do 8 times 2, which is 8, or 4 times 2, which is 8. Square root of 7 times the square root of 7. And if you skip straight to the 7 part of that, that's okay. But it's also 7 times 7 is the square root of 49. Square root of 49 is 7. And then there we go. All right. Letter L, I can simplify. So again, outside with outside, inside with inside. I can divide 4 and 8 by 4 to get 1/2. I can also do inside with inside. 8 and 2 would give me a 4 and a 1. So if I rewrite this, I would have in the numerator 1 times the square root of 4. You can put the 1 there if you want. You don't have to. The square root of 4 over 2 times the square root of 1, which is just 1. I can still simplify. Square root of 4 is 2, which would just be a 1. Okay, so on letter M here, again, same mindset, outside with outside, inside with inside. The 7 halves, so you're thinking to yourself, can you divide both of those by the same number? You can't. And then, so you keep the 7 and the 2, but the 6 and the 3, you can simplify to a 2 and a 1. Because you can divide both of them by 3. At the end, so I have 7 square root of 2. 2 times the square root of 1, which is just 1. And you could put that in the denominator, but it is not necessary. For letter N here, 7 I can't simplify. 5 and 3 I can't simplify, but I have to get rid of that square root in the denominator. Whatever I do to the bottom, I also need to do to the top, which would give me 7 square root of 15 over 3 times 3. This would give me a 9, which turns into a 3 on the bottom here. Can't simplify 7 and 3. Square root of 15. I can't divide by 4 or 9, so I'm done. For letter O, I'm going to multiply top and bottom by the square root of 2. And simplify. I would have 12 times the square root of 2 over square root of 2 times square root of 2 is square root of 4. Give me a 2. But then I can simplify 12 over 2, which is just a 6 square root of 2. All right, we're getting there. 2 more rows. So this, top and bottom by the square root of 3. I would get 24 square root of 3 over square root of 3 times square root of 3 is the square root of 9, which is just 3. Hopefully we're starting to see that shortcut there. The whole purpose is to get rid of that square root on the bottom. 24 over 3 is just 8. I get 8 square root of 3. For letter R, I can simplify 18 and 2 to get a 9 in the numerator. Top and bottom, I'm going to multiply by the square root of 2. So I have 9 square root of 2 over square root of 2 times square root of 2 is just 2. 9 and 2 I can't simplify. One's inside here, one's outside, so I am done. 27 and 3 I can simplify. 27 divided by 3 is also a 9. Multiply top and bottom by the square root of 3. 9 square root of 3 over 3. I can then simplify to get 3 square root of 3. Letter T, top and bottom, square root of 5. I would get 20 square root of 5 over 5, which would just be 4 square root of 5. Letter U, outside with outside, inside with inside, would be 4 square root of 24. Before you circle, make sure you ask yourself, can I divide the inside by a 4 or a 9? This one I can with a 4. I get 2 square root of 6. 4 times 2 square root of 6 is 8 square root of 6. Boom. And the last one. 6 times the square root of 2 times 2, which is 4. 6 times 2 is 12. And I do not expect you guys to be professionals at the moment. We will practice it when we get back in class.